Welcome to Chapter 6, Lesson 7, Equivalent Expressions. This skill is brand new, so we're going to start off with some important vocabulary terms to know. It says when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. We were introduced to this term in a previous inquiry lab, so if we look below at the example 3x plus 7 plus x, 3x, 7, and x are all terms because they're separated by that plus sign that's there. Then our next key vocabulary word says the numerical factor of a term that contains a variable is called the coefficient. So this only applies to terms that contain a variable, like 3x or x. And the number that comes before the variable is the coefficient. So in 3x, my coefficient is 3. In x, you may look at that and think it doesn't have a coefficient. But it does. There's a coefficient there that's understood. Okay? The coefficient there that's understood is 1 because that is 1x, and we've talked about that before, how they really, with algebra, they don't ever put 1x because you can only see that there's 1x there. So the 1 is understood that that's the coefficient there. Okay? Then we have a term without a variable is called a constant. So in this example, 7 is a constant. Okay? Then we have like terms. Like terms are terms that contain the same variables such as x, 2x, and 3x. So, in this example, 3x and x are like terms because they both contain an x. 7 is a constant. It doesn't have an x, so it can't be combined with them, and it isn't a like term. Let's look below at the graphic organizer to label it accordingly. This first box up top points to 4n, 2n, and 9. All three of those things it's pointing to are terms. So these are the terms of the expression. Okay. Then this box over here is pointing to the 9, and that 9 is just a number. Okay. It's a constant. So it's called a constant because the value of it stays constant. It never changes like with a variable. Right? So that's why it's called a constant, since it's only a number. Then we have this box down below, which points to 4n and 2n, which both of those are like terms because they both have that variable n. Okay. Now look ahead at the examples to get a better idea of how these terms relate to what we'll be doing.